Welcome to the last video of Unit 1. I said at the beginning of the unit that statistics is the collection, the display, and the analysis of data. And so in this video, I want to talk about one way that we can analyze data, do an analysis. And this is for quantitative data. Right? I want to highlight this. This is for quantitative data, numerical data. All right? So, I use an acronym because if I give you a set of numbers, there would be a tendency for you, if I said, well, just describe that, most likely you would put the average. You would give me what the average is. Maybe you would give me what the median is. And that is one measure of data, but we're going to talk about different components of this because, like if you were to describe, let's say, describing someone's hair, you would talk about different elements of the hair. Maybe you would talk about the length of the hair. Maybe you talk about the color. Maybe you would talk about the texture, how it's cut and styled. And so we want to do this for data. We can do this for data as well. And we use an acronym, kind of a funny acronym, called CUSS. CUSS, the central tendency, the unusual features, the spread or variability, and the shape. CUSS helps us to remember that. And so let me run through these. And so the central tendency, or center, mean is one of these. And so for one of these, weighted mean, I wanted to kind of do a quick rundown of this, that if on a midterm, my score is an 83, and my final exam is a 95, if the midterm was 40%, and the final is 60%, I'm interested in if my grade is going to be an A, if I have to get 90% for an A. And so this average, which averages one of our measures of center. So in order to calculate this, having the weight, and so I would use the 83, right? 83 times the weight. So score times weight, and we said that was 40%, 0.4, plus my final exam score, and the final exam score was a 95, times that weight. And that weight was 60%. So there's a tendency to say, oh, I can take the average of the 83 and the 95, and that will get me an 89, and that's not going to be an A. But if I'm weighting it, and so I would do 0.83 times 0.4, or 83 times 4 if you wanted, yeah, times 0.4, plus my point, doing very well on the final, 0.95 times 0.6, that gives me a 0.92, 0.902. 0.902, which is above that, and so yes, that would be an A. That would be an A. And so there's different ways that we can calculate the mean, but that's one. I won't even go through the regular way of calculating the mean. People know that. The median, the middle value in an ordered set of numbers. We use that sometimes. We rarely use mode. That's rarely used. Okay. So when we add something called an outlier, and an outlier is kind of a stat word that people have heard. We don't use it a lot, but we use it some. The mean will be more impacted than the median. median will be less impacted by an outlier. Okay? And so we would say that the mean is less resistant to outliers, or that the median is more resistant to outliers. In other words, the mean will change more than the median. The median might change some, but not as much as the mean will. Okay? And we'll talk about that throughout this. All right. And so, again, just a quick data set. If I calculate this mean is going to be 70 for the blue numbers, and the median is also going to be 70. But for my red set of numbers here, I'm just making this up, my mean is now going to be 100. But my median, again, I count out from the outside, so these go away, and so it's going to be the middle here, 72.5. The median barely changes, it's 72.5. The mean changed much more than the median when I added this outlier. Okay. All right. Okay, and so now we're going to get into stuff that you probably haven't worked with very much. Okay, first of all, you see all these formulas. Do not be afraid of these. You're not going to have to manually calculate these. It's not really, well, I'll show you how to do things on the calculator when we get into things, but it's really not a big thing. But I want to talk about this. Again, I'll talk about the C, the S, and the S. Those are the more important thing in CUSS. The center, the spread, and the shape. Okay, and so we have different measures of spread. And so one of these is standard deviation. And if we remember from the beginning of the unit, sigma is the standard deviation of the population, and S is the standard deviation of the sample. Okay? All right, and so we've got 4 friends that went to wing night, and this is how many each of them ate. And so if we're talking about the typical, the measure of center, for both the mean and the median, it's going to be 25, right? Both mean and median. Okay? But nobody actually ate 25. 23, 27, 29, 21. No one actually ate 25 wings. But if a fifth person came in, that would be my guess, because it would be kind of in the middle of whatever everyone ate. It's different than if every one of these 4 had eaten 25. I would probably predict 25 for the fifth person if they had a fifth person walk in. I'd have a lot more confidence in that 25 prediction because there's less variability. Okay, so standard deviation is basically measuring this, and so it's basically the typical distance from the mean. We said the mean was 25. Well, 27 is 2 more, 23 is 2 less, 29 is 4 more, 21 is 4 less, and so there are 2 that are 2 different and 2 that are 4 different, and so your standard deviation is about 3 standard deviation. Standard deviation is about 3, and we won't do the calculation, but it's the typical distance from the mean. That is the definition of standard deviation, and I want to write this out. Standard deviation is the, and I'm on purpose using a vague word, the typical distance from the mean. Of the data points. So there's all this formula stuff, but really that's what it's distilling down to, is the typical distance from the mean. There's other measures, and this is a measure of spread. There's other measures of spread, some of which you've seen. The range. The range is just the max minus min, which is a single value, right? And so if on a test the scores range from 85 to 100, we would say that the range was 15 points. Max minus min. There's also something called the IQR, which sounds kind of scary, but it's not that bad. It's the interquartile range, but we usually just say IQR, which is when we make that 5-number summary, right? Min, Q1, median, Q3, and max. We used that to make the box and whisker plot. It's basically the distance of the box. Is how wide is that box? Q3 minus Q1. And so Q3, and so we talked about outliers and being resistant to outliers. The range is less resistant to outliers. If we had an outlier, if someone walks in and they have 100 wings, wow, that range is going to be about 80. But if we're talking about the IQR is still only going to be about 3 or 4. So IQR more resistant. And so those are our most common measures of spread: standard deviation, range, and interquartile range. And then shape. Shape can be, you can have all kinds of different shapes for this, right? For a thing. There's a bunch of different symmetric shapes that we could have. We could have one that kind of looks like this. That kind of looks normal-ish. You all have worked with the normal curve, or even this. This symmetric. Basically, if it has a spine that you can make and flip over, that's going to be symmetric. Uniform. It's almost going to be like a block, right? But basically, if this is scores, basically every score, the same number of people pretty much get every score, right? If this is going from 80 to 100, pretty much the same proportion of people are getting 80, 81, 82, all the way to 100 uniform. Now, skew right and skew left. This is going to be show up a lot this year. So skew right and this shape. Think about it as right-tailed. Okay? And so you've got a bunch here, but instead of just going down and being symmetric, you've got a few that are way more. And sometimes incomes are like that. You'd have most of the folks kind of in one little range here, on this left side here, and then a few people, and so right-tailed. And so in this case, you would expect, right? So for this example, the median would be here, and the mean would be here. And skewed left would be the opposite. You have most of them a little higher, and then a few over here. And then, again, the median and the mean will get pushed to the left a little bit more. Okay. Just keep it, and you don't even have, it's not something to memorize, just remember that the mean is less resistant to outliers from that earlier note that we had. That the right skewed is going to pull the mean more than it's going to pull the median, and the left skewed is going to pull the mean left more than the median will. And we have other shapes that are kind of like bimodal. That's just saying it's got 2 peaks. Bimodal, something like that. And then outliers, gaps, clusters. So I can just draw one graph that'll and I'll make this maybe a histogram. So I'll make this from 0. And so I can say that there's a gap here, and let's say this is age. So there's a gap here between 30 and 40 years old. And from 70 to 80 years old. I can say there's a cluster maybe between 40 and 70 years old. Maybe you could even make an argument that from 0 to 30 there's another cluster. And then, I don't know, maybe in the 80 to 90, maybe. And I'll go through in class if we can identify what an outlier is. But that's it. That's it. So again, just practice on doing that, but this is the material for the year. Unit 1 is done.